Now let's see what we have here. So now with Pandas, we can easily load file. Okay, can easily load file, work with a CSV file you have existing, work with a JSON file, an Excel file, whatever it is. Pandas makes it easy to work with. Okay, so in this case, how do we connect to data? Right? How do we connect to data? Let me just put this here. Okay, let's just say connecting or reading files. Let's use the word reading. That's the way. Reading files. Okay, so we have the .csv. Now let's just type pd dot, then we'll do a read. Then now immediately we put a read, even before the underscore, you can see it can read a clipboard, CSV, Excel, HTML, JSON, and so on. You can see you have everything right there. You have them just right there. So let's create one data type for ourselves. One data frame, I mean. I want to create a CSV file, so we can just say dummy CSV. So we can say we have the name, the age, and salary. Okay, we have the name, age, salary, and there we can put a \n. So this will be John, comma 30, CSV file, comma separated, right? That's what we're doing. All right, let's do 50,000. So we want the \n again. Jane, 24. Let's say 45k. We want the \n again. Let's do Mike, J. Let's do Jake. Okay, so Jake, 35, 60k. All right. K now. Okay, Kimberly, 28, and let's say 5200. All right, 52k, and this is what we have. Okay, using the \n, this is meant to be another row. We want to create, because it's going to be a dummy data, so we're trying to create this ourselves, and we'll be using the file opening method in Python. Okay, file handling method, I mean the file handling method in Python. So we'll do it with, then we'll say open, then we'll just say this dummy data .csv. So W is for write, so say W, then we'll say as F. Now in here we'll just do F the write, the dummy data we created, the dummy CSV. Okay, so we want to write this as a file, and just right after there we can okay, just leave it in the same cell, so we can create open, then we can say df CSV, then we can read it normally like a CSV file. So we'll say pd.read underscore CSV, They'll open it and then pass in the dummy data that we have here. Control C. Oh, dumb. That's dummy. So copy this and paste it right there. Okay. So down here we can now print. D underscore CSV. Okay. So let's go through this. At this point, of course, this will be \n is going to a new line. So basically creating a CSV file. We already ensure that we have comma all through CSV. Okay, that's correct. So we already ensure that we're using commas so that we get a comma separated value file. And then we're using the \n. We'll just want to create a small data that we can work with. And we'll say with this data, this file does not exist before, but it will upon running this code. Okay, and we're passing this to read it as a CSV file. We're saying pd.read. Now read this file that we're creating at this point as a CSV file. So let me say creating file. So they should be creating a CSV file. Then down here, this will be reading file, reading the CSV file. All right. So let's execute this, and it's executed. Let's execute this, and you can see that we already have the file just like that. Okay, so let me take this out. Okay, so let's run this again so you can see how well it is now showing. So I've been able to create a file like this, right? I've been able to create a CSV file just like this. Now, next thing we want to do is let's inspect our data. Let's know our data. I want to find out what is in our data, right? And since we already covered all of this, let me take this out. We'll just what is our variable name? df underscore CSV. Okay, let me comment all of this. Okay, print. Then we'll do the same thing for this df underscore CSV. Okay, that's .add dots. That's how we're getting the error. The dot wasn't there. So run that again. So we'll get the head, the first 5 can pass in just 2. We know how the tail works. We know how the info. We have not seen the info before. So let's do the info. df underscore CSV dot info. If we execute that, you can see what we have. Just basically the details of the data, and we also have the memory usage as well. So we have done describe. Let's check shape out and columns. Okay, so these are useful options right here for us. dsv underscore CSV, df underscore CSV, and df underscore CSV dot columns. Okay, so it has to be plural columns. So let's run the shape first. Let's comment this out now. Run the shape, and it's telling us that is what? 4 rows, 3 columns, and that's correct, right? 4 rows, 3 columns. That's the shape of our data. And if we run this, which is the last one, you can see the column names just like that. Okay, so let's jump into some important things about our data. Let's start with selecting the data, right? We've seen the basic things that we want to see here. So we can now start seeing maybe selecting the data, sorting, filtering, and the rest. Then we'll look at how to handle missing values. Let's expand this, and so we want to select data using the loc and the iloc. Okay, so the iloc is using the index, but the loc is just using the name. Okay, as you probably have guessed, loc is simply location. Okay, so let's look at what we have in our data. So up here we can just print the daf underscore csv, so that we can grab what we have in there and work with that particular one. Okay, let's just network. We'll just wait for it. So this is what we have. So it has printed. So let's say we want to grab the third row. So we can say df underscore csv. Then we'll say dot loc. And then in this case, we'll pass in the row index. Okay. We just look at different methods of selecting data, of grabbing data, and then we'll move on gradually. Network is really being a problem right now. You can see what it did for us. So since it's just a row, so you grab it, it's showing it as a column. So you can see df.loc2, let's just say grabs row 2, right? Row 3, index number 2. All right, row 3, index number 2. So we can pass in this to grab the data. So what if we want to grab more than one? So we can say df underscore csv dot location, and this time we want to grab let's say more than one row. So we can say 0 to 0 to 2, so that it will pick the first and second row for us. So 0 1 2, so 0 1 2, 0 1 and 2. So you can see that we have been able to grab 3 rows, right? We have been able to grab, if you look at it, John, Jane and Jake. John, Jane and Jake. So I've been able to grab that successfully, and it's returning all the columns, right? What if we don't want all the columns? What if we don't want all the columns? So if we don't want all the columns, we can just add a comma. If you remember when we were doing this earlier, then we can pass in a list. Then we can pass in, we can just say let's use the index first. So that will be 0 1. Now this is raising a type error. So it's telling us cannot slice indexing on integer with this type of indexer, with this indexer 0 of type int. Okay, so what does that mean? That means we pass in the name for the column axis, because they are labeled, they are named. Okay, the row can use the index axis while the columns use the name. So what do we have? Name, age, capital. Okay, capital. And then you can see I've been able to grab the name. So let's see if we run this. We grab the name. If we put in city, now you can see the problem is saying, oh, do we have city? Let's go back. We don't have city. So come here, say salary. Now you can see we can grab any of the columns with a certain number of rows. Okay, so if we want to grab just the age and the salary, we just put age colon salary, just like that. Okay. However, we can also do something like this: df underscore csv dot lock. Okay, and then we'll pass in a square bracket. So we'll pass in this, then we'll say let's say 0 comma 2. Then we'll come out of the bracket, put another comma, open an underscore bracket, and then we'll grab the name. We want to grab the salary. So if we execute this, now it's grabbing specific rows and specific columns. Okay, remember we are not using range in this case, we're just grabbing specific rows and columns. So grabbing specific rows and columns. So this one is grabbing same thing as well, right? Same thing as well, but this is more of a range, right? It's just more of general range. So from this to this, but this one is, it can move, it can grab between the lines, right? So we can skip name, we can skip age and pick name and salary, but if we use the column range, it picks everything. Okay. We can also do a conditional grabbing. We can do a conditional grabbing, but I think we are filtering data here. Okay, so we'll do that when we get there. So we can do a conditional grabbing. This is the iloc, the lock method. So just say lock method. So now let's look at the iloc method. So we want to look at the iloc method, and this one uses position based, right? It uses position based. So we can say df underscore csv dot iloc position, which in this case simply means index. Okay, so iloc, and then we'll pick 1, for example. If we execute, you can see it's grabbing what? Jane. If we go back to our data, Jane, don't forget that it's using the index, so it's grabbing this particular person. Okay, we can grab, let's say, the first row and the second row. So df underscore csv dot iloc, then we'll do this. Now, so that you can have clarity, we will use 0 to 2. Okay, I want us to use 0 to 2, so just say 0 colon 2. Now, what is that grabbing for us? 0 and 1. However, when we executed this, if you remember, this was giving us the first 3. Why? Because this is location, so this is acting. Now these numbers you're seeing here are, even though they are by default, they look as an index, they are a direct access. But when we use indexing location, let me simplify that. When using location does not use index, so he's seeing this as an address. So grab 0, grab 1, grab 2. Okay, but when we are using index, by default the last value is exclusive, and that is why it did not pick Jake in this case. So that clarity is important, so that you just get it that way. So how else can we grab data? Can grab data. We can also grab certain columns. So if we say, for example, 0 to 2. Now when we try that at this stop using iloc, when we tried that using loc, it ran into an error. Why? Because it's location, it doesn't use index. But now we are using index, so we're saying grab 0 and grab 2. Of course, 2 is not inclusive, so it will only grab the first and second column. Okay, the first and don't forget, it is always row first, then column. Row first, then column. Row first, then column. Okay. Right. What other way can we grab? Let's say we want to grab all the rows and the last 2 columns. df underscore csv dot iloc, and then we'll put in this, we'll say all rows and the last 2 columns. So for us to do that, we'll just say column. That means grab all rows. We're not specifying starting point and ending point. Okay, so let me put that, let me add some space. All right, so you can see that clearly. So from the beginning to the end, after that we want to pass in what we want to grab. So since it's the last 2 rows, 0, 1 and 2, just have 2, so we can put what 1 and then column, since we're grabbing everything. So if we run this now, this is now grabbing the last 2 columns but all the rows. Okay, all the rows, just like that. So yes, these are some useful ways of grabbing rows and columns. Okay, so some useful ways of grabbing rows and columns. Mind you, this is location method, iloc method. Let me put them together. And we also have the native way we used earlier in the Pandas series. That's passing the name inside the data directly, inside the square bracket directly, right? So you can say using column names. All right, that's the way it is. Column names, not column name. Okay, column names. Yeah, column names. Okay, so we can grab, can just say df underscore csv, and then we'll pass in. You can see it's giving us age. If I want to grab only the age, we'll run that. We're grabbing only the age. If we want to grab, let's say the name, we'll put in the name, just like that. Can grab more than one salary, just like that. We pass in a list of lists to grab in more than one column. So you see, we're grabbing the name and the salary, something like what we did here. But here we're also specifying certain rows that we want to grab. Okay, so we can do that as much as we want. Okay, so the first one was age, so let's take it back to age, and I'll remove the unnecessary double square bracket. All right, so we can also grab data this way. All right, so this is just some few ways, or majorly the key ways of grabbing data using the loc, which is location. If you want to grab certain rows, you use the label, because do not forget, this is the label 0, 1, 0, 1, 2, right? So 2 as a location, but it's row 3. 2 as a label. Okay, 2 as a label. So you can use the location method, the iloc method, and also the column name G, using the column name method. All right, so let's look at how to sort data. Can I collapse this? Is there a way? Did I make it possible? Okay, I didn't. All right, let's just look at how to sort our data. Come in here and say, let's just say we want to sort by age, since we have the age. Say sorted age sorted. All right, so age sorted. Then we can say df underscore csv dot sort underscore values. You can see say sort values, and then we'll do that. Then we'll open it, and then we'll pass in a by. You can see how straightforward it is, right? We'll say by age. That means we want to sort by age, and then we can pass in the order ascending. Then we can say true. That's from lowest to highest, just like that. And then if we print age sorted, age sorted df, I can remember is a data frame, not just a variable, a random variable. Okay, so age sorted df, and then we execute that. Then you can see it has now sorted them by the age. So it's as simple as that. You can sort by the age, sort by salary, and whatever it is you want to sort by. Okay. What if we want to sort in descending order? It's simple. Just say sort ascending is false. Okay. What we have ascending right here, just say ascending is false. So let's just sort by name so that you can see that it doesn't just sort using numerical data. Okay, so just copy this, and then we'll say name sorted this time. Name sorted, and then this time we'll sort in descending order. Name sorted, and then we'll say we're sorting by the name, and then we'll say ascending is false. That's all. So in this case, we'll be saying Kimberly first. And you can see we're having Kimberly, then John, then Jake, then Jane, then Jake, just like that. So you can sort on any column at all. You can sort on any column at all. So the next thing for us to look at is filtering. How can we filter our data? Quickly, you can just pause the video, try to sort by salary. And like I said, it's very easy to do. So let's say we want to find people. Let's say we want to find people older than, because we don't know if they're customers, they're students, whatever it is, or let's say employees. Let's give them a name, employees. We want to find employees older than 25. So that will be picking, okay, we want it to pick 2. So we can say older than 30 or 30 and above. Let's say, let's use the word 30 and above. So grab employees from 30 and above. So we can either save that in a variable, or we can just try to print that directly without really saving it. So in this case, we're not saving it. If it's something we want to reuse, it's good that we save it. But in this case, we just want to demonstrate it. So I'll say df. Let me take out the print so that I can see it clearly. Filtering data. Df underscore csv. We'll open a square bracket, and then we'll pass in our condition. So we'll say df underscore csv underscore csv. Now, what do we want to do? This is the condition. Do not forget that. Now, don't be confused why we're using this way. This will return boolean. Only this will return boolean. So the boolean will now pass into the particular value. And take a quick take a quick look again on how we did it earlier. Okay. I think that was in NumPy. Yeah, I'm thinking NumPy. Yep. So yeah, we'll just say df, and then we'll specify the column we want to filter on, just like that, age. Then we'll say age greater than or greater or equal to 30. So let's see what that prints for us. And then you can see we're getting just 2 people like that. So what else can we filter? We can have multiple conditions. Okay. Employees, older employees from 30 and above. Now we want to use multiple condition. We want to use the age and the salary. So I want to say df underscore csv, and then we'll say in this case df again underscore csv square bracket age is greater than 25 and df in the square bracket salary. So salary is let's just say salary is greater than, let's look at all the values, 45k, 50k. So let's say salary is greater than 50k. Greater than 50, 1 2 3, just for readability, right? Just for readability. So we want to see people, say combining condition, chaining conditions using and. All right, now do not forget that if we run this, we'll get a shout. And what is the shout? It's just saying there's an issue. Wait, let me see, df underscore salary. So it's saying key error salary. Let's check. We have salary right here. So what are we supposed to do? Conditions are wrapped in parentheses. So there are two different conditions, so wrap them in parentheses just like that. Okay, so we'll run this again. Okay, now we're still getting the key error of salary. My bad. Now I can't even show you that we had a different error earlier. So let me remove the parentheses first. Okay, the parentheses are gone. So let me correct this CSV. All right. So now we are no longer having the value error or the key error saying salary does not exist. This time we're having what? The ambiguity we had earlier, and that's because we didn't wrap each condition in a parenthesis. So wrap it, condition 1 parenthesis, condition 2 parenthesis as well. All right, so you can see we're only getting 2 people. Why are we getting 2? This guy is older than 25, but he's not earning more than, because we said above. So 5,000, 50,001 is above, but 50,000 is not above 50,000. Okay, so that's why we're only getting these 2 people back in return. All right, let's say we want to use the and condition. I want to get people either named this or that, right? So I want to grab the name of the people or by the age. So finally, you can say, again, I'll just copy this since we're chaining condition again. Control C. Let this be capital. So using and, using or. Okay. So I want to grab people where the name, Kimberly, right? Kim. It's Kimberly. And we want to have, let's say salary is greater than 55,000 or salary is greater than 55,000. Okay. So say or. Now if you look at Kimberly's salary is 52,000, but we'll still get Kimberly back. Why? Because this is an or condition, so it grabs value from both ends. So if we run that, you can see we're getting Jake and we're getting Kimberly back. Okay. And yes, you can do way more than this. You can start to do things like maybe start with. So let's say we want to pick all those whose name starts with JA, right? So let's just see that example together. Do not forget, something is important. If we check, let's check this csv.info. Okay, let's run this. you will notice that for the text value is saved as an object. Okay, so when we're accessing them, we cannot access them as if we're accessing a string directly. Okay, so what do? Df underscore csv. Let's say we want to grab employees whose name starts with um let's say ja, right? So df.csv, then we'll pass in the name, then we'll say the name. Now we have to say dot str first, so we're picking the string. All right, then we'll say starts with, which we have already done before, right? The normal starts with that we know. Then we can say ja. So if we run this now, so we're getting, why is it printing? Okay, let me comment the ds.info. So you can see it's printing those whose names start with J. Wait, J. Oh, okay, John. This is J. O. All right. So you can see it's only picking these two people. Do not forget, you must not omit the string. If I run it this way, it tells me series has no attribute starts with. Okay, so do not forget that. All right. So yeah, you can still do much more with pandas. You can see we're doing them in chunks, so eventually we'll still be loading in much more bigger data where we can now do much more with it. Okay, so how do we rename column? So let's say, for example, I want to rename column, the salary column, as allowance. Maybe not salary, let's just say it's an allowance. So I can say df.csv, then I'll say dot rename, then I open this. I can pass in columns. Okay, then we'll pass that as a dictionary. So basically old name, okay, old name, and then new name. That's how it works. So if you have more than one, you pass, you just keep passing it like that. Okay, so in this case it's just a single name. So I want to convert salary, I want to change that to want to change the salary to allowance, right? Sorry, not a comma, a colon, allowance. Okay, so I want to print df down here, df underscore csv. Let's rename it, and you can see. Okay, now it is not showing anything, right? Because at this point, if we print it directly at this point, or let me just do it this way, I'll comment this out, and then we'll run this again. So you can see it's showing allowance, but once I uncomment this and I run it, it's still showing salary. Why? Because it is not overwriting it. How do we make sure it overwrites it? We'll pass in another argument, and it says in place, and then in place will be equals to true. So if we execute this now, it has now changed completely to allowance. So let's change to full name. Now we can rename all column at once. To rename all column at once, we just do df underscore csv, then we'll say columns. So this is easy, but we must make sure that we pass in the number of columns. It must match the number of columns we have. So we can say renaming a column, renaming. You can also add prefix to columns, so renaming all columns at once. So right here we just have to pass in, so we can say full name instead of name. We want it to be full name, then we want age to still be age. So let's assume we changed it earlier to years. Okay, so we could have just renamed it, and then we'll say this will be salary. So we're taking this back to salary. I want to print df underscore csv down here. I will execute that, and you can see we're now having it as full name, age, and salary, right? Just like that. So we'll now have it. Now, let's say I want to convert this to lowercase. I want to convert it to all lowercase, and I also want to maybe remove this space here and use an underscore instead. Okay, you can still do that. Just say ds underscore csv. Then we'll say dot columns. Since we're targeting the column, the next thing is dot str. Then we can say dot replace. Remember, all these methods we learned already because they are string methods, right? So look for space. Anywhere you find a space, replace it with an underscore, and then we can say dot lower, just like that. So now let's see what we get. So it has no attributes lowercase. Okay, let me do dot upper. Okay, let me do it one by one, probably because I'm chaining it in this case. Let's run it. Okay, so it has changed, but it's supposed to happen on a go, probably because I'm not doing it first. Let's try it again at this point. Dot lower, dot lower. Okay, I guess it's not picking that directly, so it's not allowing us chain anymore. So I can now say df dot columns, then I just say dot str first and then dot lower, just like that. Then run that, so we can see everything is now on lowercase. So if we print df underscore csv, oh, of course we have to overwrite df underscore csv goes to this. Where's it again? Okay, so say df underscore csv here as well. Okay, so this way we want to override the variable, or a better way to do it is to just do it in one line. So let's see how we can do the replace this in one line. By the way, do not be tempted to put this this way. So here should be, let's use the variable method df underscore csv dot dot columns. Okay, very important. So do not make the mistake of passing it into the variables directly. Let me just comment all of this. Okay, so it doesn't run. So if we run this, now we have full name, age, and salary. The next thing we want to do is to combine the lower, the lower and the replace in a single go. Okay, so let me uncomment this now. So we have the replace. So I'll grab this like this, then bring it to the front. Then we'll take all of this out, and then we'll just say dot columns. No, short form, dot columns. We can use this method as well to do it. Here we'll pass in place equals to true, but since we can't pass in place like this, we pass in what we use it to overwrite the existing column values. Okay, we use it to override the existing column values. And yeah, let's execute this. Now you can see now it's looking nice. Full name. So we just have to call str again. Remember earlier, I think I missed that before, it just came now. I think earlier we were doing something like this. Let me run this, and it was running into an error. So we just added we just had to put dot str then dot lower like that. You can see we have it nice and clean. just like that. Okay, so let's move on to the next thing. Let's say feature engineering. Feature engineering is basically creating new column from existing column to add more meaning to the data. Okay, so and that is what we want to look at. So let's say we want to create, for example, want to add, let's create a test first. So you see how it is created. We'll just multiply age and salary. That does not make any meaning. We'll just want to use it to see how to create a new column, because we can barely do any feature engineering from this existing column, except we want to do age group, right? Using if age is this, if age is that, and all of that, right? Let's just go with the age group, since we can make meaning from the age group. So we can just say df underscore csv. And how do we create it? We just type it, just like when we're doing a dictionary. We type the variable name, then we'll pass it in as if it exists. So say age group, and then we'll say this will be df dot df age, right? The df age. Then we want to apply. So dot apply lets us write a function inside here. Okay, so dot apply. What do we want to apply? We'll say a lambda function of, let's just say x. And what do we want to do? Remember, we want to say, let's look at the ages that we have. Let's look at the ages that we have, and we can say if the person is below 30, right? 30 and above, that's middle age, since we don't have older people in this case. Or let's do old and young, or adult and young. Yeah, let's use adult and young. 25 is an adult, not really young. So old and middle age, let's stick to old and middle age. So say lambda x, and what do we want to do? Remember, lambda function, we're just supposed to now put in whatever it is that we want to do right there. So I can say if x is greater or equal to 30, right? Okay, before that, I must put what I want to see. So that will be adult, over 30 again. What did we say? Middle age. All right, middle age. Yeah, middle aged. So middle age if they are above 30. Else, we can now say young. Else, we want to say they are young. I think I should be able to. All right, so from here, don't apply. Okay, good. So I can break the code down this way. Okay, good. So do not forget, it's just the code wrap, code break that we did earlier. So you can see df.age.apply. We're saying for every age, middle age, if the age is, can just use the word age so that it makes more sense to us instead of just using. So if the age is greater than 30, should be young. And do not forget that we don't have this existing. So but once we do this, we will now have it as part of the data. So run this unterminated. So young. Okay, I did not close the single quotes. I'll just put it back there, and then run that, and you can now see, oh, this is young. Ooh. So okay, my bad. I misplaced the what's it called, the young, no, this is young, 28, middle age 35, middle age 30, young 24 is not supposed to be. Okay, what did I mess up here? Interesting. Let's see what could have gone wrong. Oh, okay. So yeah, now this is not, if you look at it, I was using df but somehow I think we declared a variable df earlier, and that was what I used. So I mixed two different data together, and that's why we're getting that. So let me run it again, and yes, it's now correct. You can see middle-aged, young. All right. So this is what we have. Let's now do a simpler version of it. So you don't feel, is it this hard? No, it's not. So let's just create a new one for, let's say, gender. Oh, I think I'll leave that up to you. For you, exercise for you, exercise for you, create a new gender column and assign value based on their names. Okay, so don't just assign values randomly, just look at the names. John will be a male, Jane will be a female, Jake will be a male, Kimberly will be a female, just like that. So male, female, like that. So give that a shot. Let's just create a new column called test. So say df underscore csv test. Then we'll say this is equals to df age times dfcsv salary. So this is df underscore csv. All right. So if this is what we have, now let's print it, df underscore csv. I'll run it. Now you can see that we have a new column, which is df underscore csv. Finally, since we have seen how to add columns, let's also see how to drop columns. Okay, we have quite different methods to do it. We can use the filter method and select certain columns, save inside a new variable, or we can use the drop method, or we can use the same thing we always use in a dictionary, using the del keyword. Now this will not let us we don't need to declare, so let's just say df underscore csv, and then we'll pass in test. So in this case, we do not need to declare in place to be true. It works just like that. But if we want to use df in place, so we can say df underscore csv dot drop. Then we'll put in the name, salary. We can pass in more than one variable. Now we have to specify the axis. Axis is equals to 1. Do not forget, row is 0, column is 1. So it removes that particular column, just like that. If we want to delete more than one, we have to pass it in. Okay, this is salary. We have to pass it in as a list. So it will just be a list of the column we want to remove. And the last thing is in place equals to true. No, please. No, we're not deleting this test. So I'll run the first one and the second one. And the second one should probably throw an error because by the time it gets there, it's not available again. So, but let's comment it out so we'll see how it really works. And all of these are best done on separate lines so that it doesn't rewrite our variable every time, on separate code cells, so that it doesn't rerun and rewrite all of this. Okay, so it's not necessary at all. So let me just grab all of this, then cut. So Control MB, paste that in there. So we can say deleting columns or dropping columns. Yeah, right word, dropping columns. So let's run this. I'm going to drop test, and boom, you can see we ran this and this is what it's showing us. Test is gone. So now we'll comment this out and try to run this again, and then we'll see what we'll get. So it's giving us an error. It's saying, oh, test not found in the axis. That means that column no longer exists. So let me comment it out and run our data frame normally. And you can see this is what we now have. And yes, we have been able to see some basic and much more important things with that. We can still go all the way to do things like maybe starting with a particular column, starting with these. The manipulation can keep going on and keep going on and keep going on as much as we want to do it. Okay, so let me collapse all of these. These are basic operations that we should be able to do as a data professional. So sorting and filtering, selecting, sorting and filtering. Now the next thing is handling missing values.